So, good morning, students. In today's class, we shall discuss the effects of the transient on the equipment. The several electrical equipments which are very sensitive and which are frequently used in the electrical power system. So, again, the transients, as I told you, it is the power quality disturbance that involve destructive high magnitude of the current or the voltage or the both. It may reach towards the thousands of the voltage and amperes even in a low voltage system. Such a phenomenon only exists in a very short duration from less than 15 nanosecond so long as 50 millisecond. So let us discuss the effects of the transient on the equipment. So I am explaining it because I have not included in this slide. Please listen it very carefully. So starting with the electronic equipment, the effect of the transient on the electronic equipment will result into the malfunctioning and produces the corrupted result, unwanted result, errors. Efficiency of the electronic devices will be reduced. Improper selection and installation of this transient voltage surge suppressor can result into the failure. So, like on the motors, the transient will make motors run at a higher temperature due to increased I2R losses. Transient degrades the insulation of the motor winding, resulting into the burning or the fire alarm. It increases the motor losses, hysteresis losses, and its operating temperature. What are the effects of the transient on the lights? That fluorescent bulb and ballast may get failed. Appearance of a black ring at fluorescent tube ends. Then nothing but the permanent failure or the damage of the incandescent lamp that will result into the blackout at a home, illumination blackout. On a circuit breaker, it degrades the contact surfaces of the circuit breaker and the switches. So to protect against the transient, the end user, we are using a transient voltage surge suppressor, also lightning arrestor, surge arrestor, while utilities are using the surge arrestor. Also good earthing that will reduce the transient overvoltage. So what are the techniques behind overvoltage protection? The techniques are like the isolation transformer, low pass filter, low impedance power conditioners, and utility surge arrestor. So we have discussed these isolation transformers. Then low pass filters are basically used. As I told you, this is the low pass filter. Let me show you. This is the low pass filter. The position of the low pass filter. It is to achieve the better protection for higher frequency transient. The low pass filters are used, which one composed of series inductors and parallel capacitors. It's a low pass filter. This LC combination provides a low impedance path to ground for selected resonant frequencies. So utility surge arrestor is nothing but the metal oxide varistor. We are using the MOV to divert the lightning. MOV is a semiconductor that is sensitive to the voltage. At a normal voltage, the MOV, metal oxide varistor disc, is an insulator and will not conduct the current, but at higher voltage, it caused by the lightning, it becomes like a conductor. So this metal oxide varistor is nothing but it conducts at a normal, it acts as an insulator at a nominal voltage, and the increased voltage, at an increased voltage due to lightning, it acts as a conductor, diverting the path towards the ground. So these are the utility surge arrestor. So these are the devices to protect the electrical equipment from overvoltage transients caused by the external lightning or internal switching events even. This device is used to protect the equipment in power transmission and distribution system from the utility side. Okay. So this is all about the lightning arrestor. These surge arrestor should have low impulse ratio so that surge incident on a surge arrestor may be bypassed to the ground instead of passing through the apparatus. And what is that impulse ratio? Impulse ratio is equal to impulse breakdown voltage divided by peak value of the breakdown voltage. Okay. So this is all about the transients. We shall discuss now the flickers in a next class. Thank you for your patient listening.